Here's the program that we're going to use, and you'll notice several new commands in this program. I'll walk you through what they mean. Some of these I'm going to want you to understand completely. Some of these I don't think that we're quite ready to understand. Now, we saw the integer int value, and that's when we set a variable. This time we preceded the int with the const. This is short for constant. So this is setting a constant interval called sensor pin, and all this means is that the constant integer. All this means is that this value is going to remain constant throughout the entire program. So we want sensor pin to equal A0. And if you look at your Arduino, the pin that we connected the sensor to was called A0. So we're just naming pin A0. We're calling it sensor pin. Now we have this constant float. Float is a different type of number. Before we had integers. Integers, of course, are whole numbers, 1, 2, 3, 4, 5, 6. No decimal point. If you want to have a decimal point, you have to use a different type of variable, and that's called floating. It takes up more memory, and that's why we don't use it unless we need it. For all the programs that we've done so far, we haven't really been worried about memory, but here we need this to extra value. We need to have a decimal point here, so we'll commit the extra memory to doing a floating variable. This again is going to remain constant throughout the entire program, and this is our baseline temperature. We'll go over how we set this, because you might start with this value here, but I will go ahead and help you set one that's going to be specific to where you are. Now we do the setup, and this is a serial communication. This is serial begin. What this means is that this is going to actually get information back from the Arduino. And you're going to have this hooked up with a USB cable, and it's going to communicate back and forth with your computer. This 9600, that means 9600 baud. This is the rate of communication. This is a relatively slow communication rate given today's technology. Now we have a for command, and we are setting up pin number integers. This right here is a little bit confusing, but basically what it says is for pin number 2 through pin number less than 5, so that means 4. So pin number 2 through 4, and this pin number plus plus is adding 1 each time. So basically what this loop is going to do is it's going to go to pin number 2, set pin number 2 as an output, and then it's going to set the output to low. Then it's going to go to pin number 3, it's going to add 1, go to pin number 3, set pin number 3 to output and low, go to pin number, add 1 more, go to pin number 4, set output to low, and then it gets to 5, so that stops this condition because the pin number is no longer less than 5, and it moves out of this loop. This is a little bit confusing. I don't need you to master this, but this is the basic setup for the program. Now we get into the loop. This is what the Arduino is going to be repeating through each and every time. It's going to keep cycling through this many, many times a second. So here we declare an integer called the sensor value. And in order to get our sensor value, that's going to come from our sensor pin. Remember up here we declared sensor pin is A0. If we look at our Arduino, we have A0 right here. So in other words, what this is asking us to do is it's asking us to find the value of A0 and record it as a variable called sensor value. Then we have this serial communication, and it's going to ask us to report back or print on the screen the text, sensor value, and colon with a space next to it, then it's going to ask you to print what the actual sensor value is. And we can go ahead and look on the serial monitor. We access the serial monitor by pressing this button up here. When we access that serial monitor, you'll see that it is typed out the sensor value here, and it is recording the sensor value. These numbers are about 155 to 160 in between those. Those are your sensor values that are coming back from analog port 0. Next, the sensor values have a range between 0 and essentially 1024. It's really 1023. So we take that number, say 160, divide it by 100 or 1024, and multiply it by 5, and that is our voltage reading. So this analog port can detect different values between 0 volts and 5 volts. And if we look at our serial monitor here, you'll notice here that these are about 160, and it's saying that a sensor value of 160 equals 0.7, almost 0.8 volts. And if we were to do a little bit of math, so according to our serial communication, the sensor value is 160. So the analog port, any of the analog ports or pins, we're using analog A0, analog pin 0, it can return a value between 0 and 1023. So that means that there are a bunch of steps here, right? There's actually 1024 steps because you have 1 through 1023, plus you have 0. So that gives 1024 steps. All right. So if the sensor value, what you have to remember here is that the sensor value is reading voltage. So if it returns a value of 0, it's 0 volts. If it returns a value of 1023, that's the maximum voltage that it can detect, which is 5 volts. If it returns the sensor value of, if the sensor value was equal to 512, which is half of 1024, that means that it would be receiving half of 5 volts, which would equal 2.5 volts. Now our sensor value was 160. So let's do a little bit of math. If we did 160 divided by how many possible steps there are, and with a little bit of rounding, we find that this is 0.16. So 160 is approximately 16% of the capacity, right? So if we had a gas tank that could hold 1,024 gallons and it was holding 160 gallons at the current time, that would equal 16% of how much it can hold. Well, we know that the voltage that it can detect is 5 volts. So it is detecting 16% of 5 volts. So if we did 5 volts in a proportion, we would get the proportion that looked like this. It would look like 16 is to 100 as X is to 5 volts. if you solve this, you would figure out that this is returning x equals 0.78 volts. You could also solve this more quickly by just doing 16 times 5. And that gives you the voltage that is being detected by pin A0. If we go back to our program, we'll see this is where it's doing that math. If you don't understand it, that's fine. If you do, that's great. We'll do a couple more examples to give you a little bit more hands-on experience with it in the coming weeks. All right. Now, the conversion factor, so here we report the voltage. So this line right here just has it print this text in the serial monitor. And you can change this to read something, well, let's not change, well, you could change this to read something different, just to, if you wanted to say how many volts or number of volts, you could do that as well, because this is just text. Then it returns the voltage. Remember, we just calculated the voltage up in this line, and it prints it on the screen. This just has it come up on the screen. Then it puts serial prints. It prints the text degrees Celsius. And here we've got to do a conversion factor to take our voltage and convert it into temperature. And this equation just comes from the nature of the temperature sensor we're using. A different temperature sensor would have a different equation. You can't really understand this without more knowledge, so you'll just copy this in there, and that tells you how to take the amount of voltage and convert that into a temperature. And then we have this serial print, and there's something special here. It says LN, and then it has you report whatever the calculated temperature was. The LN, that just means put a new line after this one. So if we go back to our serial monitor that's here, and you turn off the auto scroll so you can kind of look at what's happening here. It is giving you a sensor value. It puts the text sensor value. Here it puts the variable, it puts the number that's being read by the sensor. Here is our calculated voltage, and here is the conversion into degrees Celsius. Now, when you do this and you're not touching the temperature sensor at all, it should remain pretty constant, and you're going to want this number, whatever it is when you're not touching it, to be your baseline temperature up here. Right? That is what the temperature is starting at before you put your fingers on it to measure the temperature. Now, let's control our LEDs. And that's what all these down here do, is control our LEDs. So here are the conditions that are going to make our LEDs light up according to this program. Let me just explain the conditions to you first of all. Now the baseline temperature should be whatever the temperature is in the room. And if it's at the baseline temperature, 3 LEDs should be off. And then if we add 2 to the baseline temperature, so this line, so let's just say we've got a thermometer here. And here's what the baseline temperature is. Here's the baseline plus 2. Any temperature in between the baseline and 2 degrees above the baseline will leave all 3 LEDs off. Then if you add 4, so the baseline plus 4, then you'll get 1 LED on. but it has to be between 2 and 4 degrees above the baseline in order to get that one LED on. If it's between 4 and 6 degrees above the baseline, then you're going to have 2 LEDs on and 1 off. And then if it is greater than 6 degrees above the baseline, you can have all 3 LEDs on. All right, so that's the basic idea of this program that we're going to look at here. So if you look here, here's the first condition, all 3 LEDs are off. Here's the second condition, you've got 1 LED on and 2 off. Here's the third condition, 2 on, high, high, and 1 off. And the third condition, you've got all 3 of them on, and the temperature is greater than or equal to the baseline temperature plus 6 degrees. So in all these cases, here the temperature is less than the baseline temperature, all 3 are off. Here, the baseline temperature, the temperature is greater than or equal to whatever the baseline is plus 2. So the baseline plus 2, and it is less than the baseline plus 4. So that's in between here and here. That gets 1 LED on. Then we've got the temperature is greater than or equal to plus 4, but less than plus 6. So that's between here and here. We've got 2 LEDs on. And then we've got the temperature is greater than or equal to the baseline plus 6. We've got all 3 LEDs on in that situation. All right. That's the basics of it. I want you to see if you can play around with this part of the program a little bit. You could potentially do things such as adding a few more LEDs, changing these ranges. Maybe you have an LED for every 1 degree temperature, and you could do that. Maybe you could think of something else that you could have happen. But go ahead and first of all, make sure you get this working, the basics of this working, and then I want to see it, and then show me your modifications to it and what you do to the program. All right, this is a difficult jump, a big jump in our difficulty. See me for questions, I'll be around. I don't expect you to understand every part of this program, but there are some ideas that I think are much more straightforward that you can work with.